this, yeah. Good morning, everybody. For those of you who haven't heard of me before, that's probably really lucky for you. But if you are familiar, I run a podcast at packetpushers.net where I tend to talk reasonably nerdy. We often have Ivan on the show, and we try and get guests in and around the world and talk about nerdy stuff. Today, the topic of my talk is about OpenFlow and the rise of software-defined networking. It's going to be a big topic in the future. It's going to be pretty big. There's a lot of reasons for that. But what I wanted to do is, instead of sort of waving a flag for OpenFlow and saying how fantastic it is and you should rush out and start doing some stuff about it, what I wanted to do is do the nerd thing and start from the bottom up. So instead of talking about it as some amazing software development that the future is going to hold, let's have a look at it in terms of the nerd technology talk a little bit about what it is, then how OpenFlow works, and then let's finally, when we understand how the technology works, let's talk about why we would want to do that. Okay? So, what is it? Nerd glasses on, because we want to get into the technology of this. Right? So, all of us would be familiar with the concept of a routing engine or a switch actually having three planes. A forwarding plane where the data goes through, a management plane, which is where we CLI, SSH, SNMP, and then we have a control plane. Today, control planes are built out of OSPF, BGP, LDP. There are multiple control protocols that do things in our networking things. Now, in a typical network, every device has a forwarding plane in it. And when a packet comes in, the router then decides which interface it's going to send it out of, comes up to the next one, chooses which interface to send it out of, and so on until it gets through the network. Okay? Pretty straightforward. The question is, how did our forwarding plane make that decision? And in the routers today, all the vendors have different names for these things, but at the end of the day, forwarding information tables in a router, forwarding information base is what Cisco calls it, FIB. Let's stick with FIB, right? Nice, convenient term. And in each of our devices today, we have RIBs, the routing information base. So in the routing table, we create all of these different routes that we stack up, and then we derive those down into a forwarding table. So in the case of Cisco, they use KEF, and they say this is the layer 2 interface. So what we'll do, we know this is the IP, we know this is the destination, so we'll create it, and we'll record, and we add the layer 2 interface, and that's where it's going to go. And that's my RIB is feeding into the forwarding table. Routing information base is formed, and that's what makes our forwarding decision. So how do we load the RIB into the FIB? We use a routing protocol, OSPF. So the routing protocol builds up a list of destinations in the network, the RIB loads itself into the FIB, and that's how packets are forwarded. Cool. So, are routing protocols good? Anybody want to think a routing protocol is a good idea? Worked pretty well for the last 30 years. Been pretty exciting, right? Works, you know, we know it, it's good, right? Reliable, proven, deterministic, we all understand it. OSPF is pretty arcane. It's a fairly low-level abstraction of a simple Dijkstra algorithm, and it's taken us 30 years to sort of use it, which isn't so great. Maybe we could have done better. But self-healing, very autonomous, and the great part about the routing protocols we have today, including BGP, is that they're inherently scalable. Right? Simple, dumb, trustworthy, cool. Well, what's bad about routing protocols? Routing protocols we use today are loosely coupled, right? So when you go over here and you configure your MPLS, your upstream labels do something, right, according to the rules. But if they break, the whole system breaks. It's not tightly coupled. You don't know what the next guy's going to do. You route by rumor, okay? That's textbook 101 sort of thing. We do everything hop by hop. Why do we not plan a path end to end? Even MPLS today, which attempts to create an end-to-end circuit connection, is still hop by hop. All the LDP does is promotes a hop-by-hop path to manage a flow. The systems are very homogeneous, so they're flat. We can't make much of a difference to them. They resist change. We don't inherently want OSPF reconverging every 15 minutes. Right? We don't want our BGP flapping so much so that we actually use route dampening. We suppress routes for hours at a time, which is kind of crazy. We have very limited capabilities to influence them from external source. How many times do you update your router table to say change the routing table from this to that? We're scared of changing it to some extent. A lot of people are anyway. We don't have any load-based routing protocols. We don't have any routing protocols that say once you get to this load, do this. We've got no systemic way to make those changes. and everything is all destination only. So we only route according to the destination as a general rule. MPLS sort of still only gives us destination routing, although it's a bit of a twist on that idea. So what if instead of routing protocols, building a rib being loaded into a fib being loaded into the forwarding table, right? What if we built a controller, the Borg in Ivan's language, a Borg architecture which programs the forwarding tables. Ditch the fib, ditch the rib, ditch the routing protocols. Right? So what is a controller? What could a controller be if I took all that out? The answer is it's software, and it's a program of some sort of remote external controller that's doing something to the system. It connects to all of the devices. In the extreme forms of OpenFlow, which are being promoted today, you can actually now go out and buy Ethernet switches with an operating system, literally an open source operating system, that loads directly into the TCAM. There is no control plane to speak of. It supports no routing protocols, no spanning tree, no nothing. There are versions of that around. That's the extreme form of this, right? The controller has to build the network topology, wouldn't it? The controller would have to use an algorithm to divine, mystically gathering the information from the equipment to build a topology in some way. But that's just programming. Well, not just, right? But still. And once the controller's built the view, it could update the forwarding table via an API. Right? So an OpenFlow controller has a network that uses a protocol which we call OpenFlow to poll those devices. Now OpenFlow is probably the worst named protocol after BGP. Like Border Gateway Protocol isn't all that very useful at all, right? So OpenFlow is not the controller. OpenFlow is the protocol by which the controller tells the system, this is what I want you to do. I want the packet to come in this way and go out that way. Right? We'll talk more about the details of the mechanics of that at the moment, but the controller is in three parts, is the key here. So what the controller does, using the OpenFlow protocol, talking to the network, builds a network model in the software. Right? So what does OSPF do? OSPF gets a database of all the networks, all the nodes in the mathematical tree, and then runs a shortest path first algorithm over the top. But we do that in every single router. What happens if I put it into a controller piece of software and it did the OSPF algorithm, calculated the forwarding tables for each router, and then loaded that forwarding table out to every device? Is that not the same thing? Any dissenters? Anybody going to yell me down? Come on. Oh, there's no fun here.
Start that discussion.
Right. And then a user interface. So now that we've got a controller that's got an entire view of the network, knows what all the nodes look like, knows what the interfaces look like, knows what the connectivity is, there's an interface, right, that we can present to the user. What would that interface look like? Don't know. We'll talk more about that in a bit, right? Okay. How does it do this stuff? So let's have a really good look at OpenFlow, just like you would understand OSPF and you would understand the LSA and the database exchange and that sort of stuff. And you understand VGP and you understand how that sort of protocol works. Let's look at OpenFlow from that point on. So keep your glasses on. Keep your nerd glasses on. The OpenFlow draft specification 1.1, we'll talk more about the pedigree of OpenFlow and why it makes good sense to consider it as a contender in a bit. In the standard, it talks about a flow table consisting of three fundamentals: matching the fields, some counters, and an instruction. In other words, we match on something, frame, packet, some sort of data. We count it. Counting's really important for NOGs, right? Counting is probably the single biggest application for NOGs today. We'll touch on that later on as well. And then an instruction. Right, sound pretty familiar? Sound like a quas table to you? Match something, count it up, and then do an action on it, don't we? So, OpenFlow as a protocol is a protocol that runs from the controller to the switch, controller to the router, controller to the networking device. In a very real sense, the definition of routing and switching goes away in a controller-based network like this. Now, I don't know if anybody's tweaked to it, but have you ever heard the word controller-based network before? Anybody here do Wi-Fi? Yeah? controller-based network, right? Where's the brains in a Wi-Fi controller-based network? Right? That's where this came from. So controller-based networking is not new. It's been around for about 50 years, ever since we first started off with class fiber exchanges, right? So it's not a new idea. OpenFlow is an asynchronous protocol. It's not synchronous particularly. It has a synchronous mode now, but it doesn't require any coherence instead of that sort of stuff. It's very elastic, very conceptually pure, and it's symmetric. I've got no idea what that means. It wrote it in the standard. I keep trying to work out what they mean by symmetric, but yeah, whatever. Match fields, right? So if we're going to match on something, we want it to match on lots of really useful stuff, okay? So if you read the OpenFlow thing, you'll see, all right, pretty good, right? All the things that we want are kind of in there. TCP, UDP, ICMP, good stuff, right? MPLS tags, VLAN tags, all the things that you would realistically expect. What you're doing today to map QoS or to do policy-based routing or something like that, that's all in there. Great. And we've got lots of good flexibility in here. What does this mean in detail, right? Okay, so Ethernet source addresses with arbitrary, whoops, I got it, it's all good. So arbitrary bit masks. VLAN IDs with, we can do, only outermost VLAN tags in the protocol today. That's a bit of a disappointment. Only match on the outermost MPLS tag. This is only version 1.1 of the standard. Subnet masks are arbitrary bit masks, 8-bit values. So sort of when I look at that, I'm sort of seeing everything's there. Well, maybe not. You know, there's a few things missing. This is a bit of a disappointment. Only the outermost tag on a VLAN sort of not real good for Q and Q, is it? Right? And this outermost MPLS tag isn't good when we're trying to do something, you know, matching on multiple tags. Maybe it'll come in the next version. I haven't actually spoken to the guys in a little while, so we'll find out some more as things go. The OpenFlow table uses pipeline processing. So what happens is you come in, you have a table of actions, it matches, and then it sets an action, and then it continues to match through the table. Right? So you have this continuous process of match, action, match, action. Anybody heard of access lists? Sounds, you know, yeah, thought you might. And then we also have this thing, this is different. This is where OpenFlow gets kind of funky. OpenFlow 1.10 didn't have it, but OpenFlow 1.1 does. Action buckets in groups. What you can actually do in a table is say you match a group for a set of functions, drop it up into a group, and then in this group you can actually have buckets of actions, which then drop it back into the table before it actually gets out into the frame. So, what's the message from there? Pretty flexible. Somebody actually put some thought into this. It's not something that fell out the bottom of a Google 20% project. It's actually structurally sound. You can apply actions immediately. You can clear actions, write actions, so you can munge the frame, and then write metadata and masks into the field, right? So just 4 simple actions can be done. We don't really care. A lot of people sit there and say, hey, you're going to specify everything. No, I'm going to use wildcards, right? The secret behind OpenFlow is to say, maybe I just want to say any MAC source to some MAC destination. Send it out port 1. Right? Any frame or packet with this IP destination on this port, forward it to port 3. Oh, and count it up. Right? So I don't have to specify every single flow. One of the most common criticisms is, are you going to specify every single flow and load that flow into a table? No. In OpenFlow, we just say, maybe we just have one that says, let everything through. Forward everything to one port, right? Maybe we have different things. Maybe we say for this source IP, send it locally. Or in this case, maybe we drop it here and then count it, okay? I didn't do a good job on this slide at all, did I really? That's not going to be very clever, right? So what you can actually do here, there are other things you can do here. You can divert them. So if you actually say, I want to pick up a flow, so you might have a wildcard route here that says source IP 192, send it to an IPS. But if you have a destination IP that's different, it would go somewhere else. So OpenFlow is a protocol, but it's mostly an API. It's about loading data into the TCAM of a switch or into the FIB of a router. Okay. What does the controller do in this network? It does everything. Absolutely everything. So, reality check. Scott Schenker, who's one of the creators of OpenFlow, says, OpenFlow doesn't let you do anything that you couldn't do on a network before, right? Absolutely not. OpenFlow is another way of doing the same thing that you did last week. It's another tool in your toolbox. And we'll talk more about practical applications in the lead up in a little while. But, as Ivan says, OpenFlow, you don't need OpenFlow to solve every age-old problem in your network. To some extent today, OpenFlow is a problem looking for a solution, right? But my proposal is that it's probably necessary. So why do it at all? Well, let's have a look at some applications for this. I want to set the output port. If I've got a packet or a flow coming into a switch and I say I'm going to send it out this port, I might actually want to say, if you're going from this source, I'll send you out this port to get to a destination. Or I might send you out, but if you're going to a different destination, I'll send you out this port. Is that load balancing? Right? If I map a different source and destination IP address and then send them out of different ports, I've just load balanced, have I not?
Can you wait for the microphone?
I'm just wondering how hypothetical this use case is, because you normally can use ECMP, for example, and I can't imagine someone doing, like, you know, per port load balancing on a large scale, because you would end up classifying every single flow, right?
No. So you could create, you can, right? You're talking about new generations of chips coming out that are able to classify 250,000 to 500,000 flows in one switch, one router.
Okay, and then you would allocate an output port for every single flow?
Potentially, sure. If you've got enough bandwidth between your controller and the edge device, sure, you could load 50,000 flows a minute.
Yeah, well, so I still don't really see the advantage over a regular ECMP with hashing.
What if you want unequal cost multipath?
But why would you want that?
You might want to have storage flowing this way and then data flowing this way, but when the storage traffic isn't flowing, you want to send the data this way to reduce the latency. Maybe you want your storage traffic to sit within a bounded latency limit, and when that latency goes over a certain limit, you want to reprogram the network so that the characteristic of the traffic flow is that the latency comes down. You derive a set of rules that are heuristically analysed and then load that into the switch so that you say, hang on, these are my 3 least latent paths. I'm going to clear the data away from that third path and start using more bandwidth down that.
Well, yeah, I see your point. I just still think that it adds a lot of complexity into, I mean, it actually requires you to first think about that, and I can't imagine someone, like, you know, if someone has a large-scale network,
yep,
they already have enough problems, and yep, they probably don't want to dig into this level of detail to, like, figure out where individual flows should go. But I see what you mean.
Right. Because everything's in the controller, it's all about the software that runs on the controller. So the controller has to build a rule set. Mm-hmm. So are we going to see a controller that can dynamically reallocate load over 3 lengths unequally against a latency next year? Probably not. You know, we'll be lucky to have a controller that can run a network with, you know, a couple of hundred switches, I should think. I've seen some betas coming out from some of the venture capital funded things. They're making good progress. But in 5 years, when you're likely to think about this, how far could the software have gotten? Right? With things like Hadoop clusters to do deep data analysis of your packet flows, you could come up with new visions into your network that you can't see today. Right? We've got new technologies coming through that make this possible. Think bigger. Don't just think BGP and MPLS. Right? You can actually analyze your entire data set and then come up with, you know, deep analysis of your flows across the system. And because the controller's getting that back here, you've got a data set you can handle into a Hadoop cluster to analyze. Right? Big data for networks. Right?
Okay, let's see.
Modify IP fields, NAT, coarse munging. Right? So if you're going to modify a field for IPv4, you can sit there and start saying, I want this QoS tagging. You want to be able to reprogram your QoS tagging on a basis. As long as there's enough bandwidth between your controller and the device, sure, you could remunge your QoS profile every 60 seconds. Why not? Modify Ethernet fields. You can set VLAN tags and TOS, so you can remap an Ethernet frame from one VLAN to another VLAN frame. So let's consider a practical application, and this is one that's actually demonstrated in a YouTube video that was done by Stanford. And what they did was they basically said, today when we use load balancing in a system, we have a client comes in through an edge, hits the core switch routes it into a load balancer sends it out to the edge. So what does the load balancer do? Just rewrites the destination IP address, right? Albeit uses some fancy heuristics about how to do that. You know, polls and probes and checks and stats and stuff like that, but that's all good. But ultimately, it just rewrites the IP header, right? So when it comes in, it gets analysed here, comes up, hits the LB, hits the edge. Great. What if I just programmed this switch to say, if I see a packet that's coming in for a given IP address, I rewrite it, say here, on the edge. So instead of actually sending it to a load balancer to rewrite it, I put it into the table. The edge switch says, I want to send that to that destination. Then I load a flow into the core switch that says, route this source destination to this edge switch, and this edge switch sends it to this server. These are the two load balanced servers, right? And when this guy sends in a frame, the edge rewrites here, forwarding table hits here, and sends it to this server instead of that server. You've just achieved network-wide edge case load balancing. Right? Hands up who's got a 3G network that needs edge load balancing? No? Gosh, they're crying out from in the UK. Right? So no more load balancers. Certainly not from a network, simple network load balancing point of view. You don't need an F5 or one of those tools to do deep packet inspection. If you do, you can still do that. You can still divert the flow here. You could even load balance load balancers and then do the deeper analysis. Okay, let's talk a little bit about why we want OpenFlow. Let's drop off from the nerd land and let's drop into business land. First of all, OpenFlow's got some good parents. They are people like Martin Casado and Nick McCown. For those of you who've been tracking these, Nick McCown, particularly at Stanford Uni, has been behind several of the networking initiatives, new systems that have come into networking over the last 25 years. He's got a number of papers and he's quite familiar to a lot of people. The big vendors are all in. Juniper, Brocade, NEC. NEC has a shipping, programmable flow is the name of it, a product for data center management today. Right? It's not just wafty words coming out. NEC is fully committed to bringing their products to market in America around the programmable flow, which is an open flow controller, and you can see a demonstration of it. Small vendors are in behind it. There's companies like OpenGear consoles, anybody? Server consoles, right? They are already producing OpenFlow compliant systems in their stuff. They've announced it today. Right? There's a flotilla of startups, Big Switch, Nicira, Pronto Systems, all venture capitalist funded. I'm not overly excited about that, except to point out that there's a whole ecosystem of vendor support going on. Juniper actually demonstrated at as part of an interoperability lab. Big Switch controllers, Juniper routers, Fortinet, there was a whole bunch of them. I've got a big photo if anybody wants to see of the whole rack where everybody was actually having interoperability testing live at Interop. Big name companies, if I could spell it, it would be a good day. Google, Yahoo and Facebook. I've met all of the people from Google, Yahoo and Facebook who are actually into OpenFlow. For them, it's huge, right? Google repurposes entire racks as compute infrastructures at a time. They'll have a rack in the corner, and that's currently configured as not in the corner, but in a data center. That rack is currently set up to be a mail gateway router, right? And it acts as, all the mail that comes in needs to be routed into the various pieces of the database. Very exciting. But at 2 o'clock in the morning, it needs to be rediverted into an analytics reporting engine. And they reboot those systems, they boot a new image, and they turn that whole thing into a Hadoop cluster that does, or whatever their name of their cluster is, and turns it into an analytics processing engine. But you want the network to look different, don't you? All of a sudden, the traffic profile that was mail and had a different set of cost settings and a different set of VLANs and a different set of processing is now a completely different profile. And you want all that to be automated. So for Facebook and Yahoo, OpenFlow is all about DevOps. Being able to hit the controller, say, do this. Sure, you're going to need an awful lot of programmers and an awful lot of testing. I'm not ignorant of those challenges, but that's the sort of thing they're talking about doing. And Indiana University has already set up the official, in other words, they set it up first, interoperability lab. They have the blessing of the OpenFlow authorities. So vendors are now submitting their products to be OpenFlow certified or compliant with the standard. Matt Davey, who's there, really nice guy. If you ever want to have a chat to him, I'm sure he would respond. He's really knowledgeable. Okay. One thing I want to make about adding OpenFlow to your network is it doesn't replace anything, right? So you can start putting it into your network today without ditching anything. It can work alongside. The original intention behind OpenFlow was literally a team of researchers at a university campus wanted to set up a research network, but the university didn't want to divert give them access to the network, because if they started fiddling with the routing protocols, that would break the campus network. So OpenFlow is designed to work alongside of it. So you can literally take this port, this port, this port, this port, that on this switch, this switch, this switch, and turn that into a sub-network. Okay? Virtual tenant network planes in the controller. So you can take your existing network and turn it into a virtual network which is OpenFlowed. And then everything else runs your OSPF, ISIS, LDP, MPLS, whatever. And you can just carve it out from your existing infrastructure if you've got OpenFlow compliant devices today. Start a pilot network. Okay? Adding OpenFlow doesn't replace anything unless you choose it to. Okay? Topology light. Unlike OSPF or BGP, inter-AS, VPLS, forces you to make certain topology decisions. The inherent limitations of those routing protocols in terms of artificial boundaries of mathematics to do with OSPF or inter-AS, where you have to mark things at certain points, right? They are arbitrary topology decisions that are forced upon you. You get no choice. Right? In an OpenFlow environment, you are topology independent. Okay? Let's just bound that rather outstanding claim. Cabling paths force topology. Right? If the only cable between London and New York goes via a certain path, then that's a topology decision that's immutable. OpenFlow can't fix that. Right? Routing protocols do force topology. Business partnerships force topology. But OpenFlow should be, once we see the final things, flexible enough to give you the choice to do a lot more with your topologies instead of arbitrary limits. It's dynamic. There is no reason why your controller cannot repeatedly update forwarding tables. Okay? Can I promise you today that OpenFlow will not drop packets? No. Can I promise you today that your OSPF reconvergence will also not drop packets? No. Right? What's the difference? Just for anybody who wants to ask that question before I get started. One of the things that I've seen recently is that some people are actually saying, why don't we shut down unneeded nodes? So routers and switches are now getting to the point where we actually want to turn them off at certain points in the time of the day. So why not power them down and have OpenFlow route around them? Yeah. You look at some of the power consumption on some of those bigger Q fabrics, some of the Nexus 7000s, they are beasts for power consumption. But you don't actually need them on 24 hours a day, you only need them on during peak time. So what if you could power something down and save electricity? And change your flow topologies on a time basis. Time of day, whether the boss is in the house. You know, when the CEO comes in, you actually want to give him the worst cost level, because that's the only way to ever get more money spent. Because if you give him the best, there's nothing wrong, because he's not experiencing any pain, right? Never give the CEO the best level. Give him the worst, otherwise nothing will change. Right. So, security tools. This is a bit underrated. I don't think a lot of people have actually given any thought to security. I know I don't. But you can divert flows to service ports. So one of the things that NEC is demonstrating in their programmable flow controller is the ability in a data center to give out a specific flow and divert it to an IPS. And when the flow returns from the IPS, they have OpenFlow rules that put it back into the path. Okay? Flexible, scalable. All right. What about that old bugbear, as Ivan was referring to, as VM migration at layer 2? So let's say we want to move a virtual host from this hypervisor, from brand X, we shall remain nameless. So what if I go into here, if I'm going to move this host, and here's the V host actually starting to migrate between here and here, I can hit this edge switch and load a new rule and say this IP address is no longer down here, send it this way. Right? And then OpenFlow goes through the network, pops all the different parts, and then when the host gets here, all of the flows in these switches now know that this is the destination of that IP address. Okay? I'm updating a flow in a TCAM. Am I IP routing at this point? No, I'm forwarding. So where the TCAMs once said, send that IP address down to here, it now sends it down to here. No ARP, no gratuitous ARP, no flush, none of the trauma of. This is a long way away, right? VMware doesn't want to do OpenFlow as far as I can tell. They don't like it because it takes away their domination of the so what they think of networking, right? VMware still haven't worked out that there's an N in networking, right? Much less an ETW, whatever. Campus applications. Indiana University, this Matt Davey I was telling you about told me a great story. They have 3,000 wireless access points in a campus, right? Students, teachers, researchers, administrators, all mobile, all moving around the campus from time to time, right? What they really got, and they've also got these locations, like in a dormitory, a student's laptop should act one way, BitTorrent, gaming, whatever. But in a classroom, you probably want to handle your BitTorrent. But in a classroom during class hours, you might want to have a different QoS profile on your Wi-Fi to conserve resources for classroom activities. So what you really want to say is, this student's laptop is down in the dormitory, he's looking at movies on his YouTube or downloading his BitTorrent, that's fine, but when he moves over here to the classroom, you might want to shut BitTorrent off. How do you do that on a Wi-Fi network that is also hosting students, teachers, researchers and administrators without using the wallop that we've got today in Wi-Fi, which is all this controller-based or controllerless and distributed applications? Gets pretty confusing. Right? So what if we just had a controller that just munged all the tables according to the rules and then just kept adapting them and kept downloading the rules to the Wi-Fi constantly? And it supports. Ericsson recently, this might be more interesting to people. Ericsson recently demonstrated an interoperability lab where their controller, OpenFlow controller here, right, and their controller is running MPLS with virtual interfaces, was running LDP to the MPLS on either side, operating with an IP MPLS core, right? Building an entire OpenFlow network in here, speaking all the protocols that we all know and love over here as a way of changing it out. And that's early lab stuff. Ericsson's investing in that. 3G networks. Perhaps I wasn't able to find any samples of this, but this is where I believe. 3G networks have got a massive problem at the moment in terms of counting user data. So people's handsets are moving around the system constantly from place to place. They already have centralized control. 3G phones are constantly reporting back to the base stations using the 3GPP protocol. But the biggest challenge is that the only way to get user control is to have DPI, deep packet inspection, right down in the core of the network. So we trunk all that data back down to where the DPI is. What if I could start doing more of that classification at the edge? What if I could count the user data at the edge instead of sending it through some sort of central gateway? So you saw before we said match, counter, instruction. Those counters mean more in a 3G, 4G wireless network, LTE network, than perhaps you might otherwise think. Okay. So just to wrap it all up, how am I running for time? 12 minutes to go. Oh, can I go back to the beginning? No. OpenFlow is still very early, okay? There is a lot of discussion, I wouldn't want to paint a picture that OpenFlow is just about to arrive. The things that Ivan talked about in terms of data center fabrics is here. Those are shipping products. Software is early stage adoption, right? OpenFlow's barely escaped from the university. But if you're looking at a 5-year to a 10-year strategy for your network, you might want to start taking some time to consider what that means and what OpenFlow might mean for your purchasing strategies in a 10-year time frame. Because I would suggest that OpenFlow will probably arrive. My resident grump over here might not agree with me, but
I agree with the Daniel.
It's all about the controller giving us a better control plane. It's not that our existing control planes are bad, but I think OpenFlow can give us a better control plane. If you've got all that data coming back to a central controller or a distributed controller or a redundant set of controllers, we don't know what the controllers will look like. I don't want to overstate this, right? Controllers aren't here yet. They're still developing them. I know there's labs. I've heard different pieces of rumours that it's been in various labs around the country for the better part of, around the world for the better part of 5 years. So it's not just invented last year. It's been happening at a sort of a fundamental level for a significant period of time. The controller is another way of defining flow forwarding in the network. Just understand that, right? Your BGP, your MPLS, your ISIS all defines a way for your packets to flow through the network, right? Flow forwarding. Wow, packet forwarding really. OpenFlow says we want to do flow forwarding, right? So it's not reinventing the wheel. We aren't suddenly encapsulating our frames into a hypertunnel and magically transporting them across something. We are just defining an alternative control plane. It's all about software-defined networking. I think the word OpenFlow might fade away and you'll see the word SDN rise. So instead of it being protocol-defined networking, which is what we have today, and specifically routed protocol networking, in terms of how we create the forwarding paths through our network, it's actually all derived from a central controller. Worth thinking that you can do both at once today. That is, you can have OpenFlow and your existing control planes cooperatively live in your network with the right software, the right systems, you obviously need to do some diligence and stuff like that, but you can do both. It's not a thing. There are many open source projects. If you go to openflowhub.org, there's around 10 different implementations of controllers. Some, God help them, even using Java, right? But, I guess, yeah, that's really going to scale. So, but they might be worth a bit of a go, right? You can pick up, there's a company out there called Pronto Systems. They're producing 48-port, 1 gig OpenFlow compatible switches for less than $2,000 US, right? So you can actually, I think there's actually a 10 gig version which is less than 5,000. So 48 10 gig ports for $5,000. And an OpenFlow controller and you're in a test environment. The other company which is very big on supporting the OpenFlow project is Hewlett-Packard via their ProCurve switching line, which has a number, there is images. So if you have a relationship with Hewlett-Packard, talk to them about getting the OpenFlow software for their ProCurves, and you can start testing it with those, right? If you're in that way inclined. You might well have some of those just lying around in your network. They're very cheap, very easy to set up. There's many more commercial projects. Judging from the level of interest around companies like Big Switch, who are venture capital funded, in terms of developing controllers, it's going to be kind of fun. I'll just have a plug here. I am hosting a symposium. Ivan will be there as well with my co-host from the show, Ethan Banks. We are running a symposium on the 26th of October. It's a live stream from San Jose. We have Juniper, Big Switch, Brocade, Cisco, and NEC attending as vendors. We have representatives from Google and Yahoo doing a moderated panel discussion on the technology and the business sides of OpenFlow. Please, if you want to, tune in on the day and you can listen to 2x2 hour discussions on OpenFlow from the horse's mouth instead of the horse's ass over here, right? Please come along. If any of you are in San Jose, there's free tickets to the event if you wish to pop along. And I think we'll be posting recordings of it afterwards as well. So please come along and look. There's a bunch of links for those of you who wish to look it up later on. I will probably post some more. And thank you very much for tuning in.